Hi, my name is Ryan Kai, and I'll be going over FRQ 2007 number 6. So, number 6 focuses on Taylor polynomials and Taylor series, which is a good one of the more difficult concepts of chapter 11. So, part A asks us to write the first 4 non-zero terms and a general term for the Taylor series of for x about x equals 0. So first of all, we know that in the given problem, f is equal to e to the negative x squared. So a good start is to fall back on our power series and remember that e to the x is equivalent to summation of x to the n divided by n factorial. Now, since it's asking us for e to the negative x squared, we are just going to substitute negative x squared into where x would normally be. With this, if we plug in n equals 0, n equals 1, n equals 2, and n equals 3, we will get the first 4 non-zero terms of the polynomial. In addition, we are asked to find the general term. However, the general term will just be this portion of our summation, which is negative 1 to the n multiplied by x to the 2n divided by n factorial. And this is how we get to our next term. Part B asks us to use our answer in part A to find the limit of this fraction. So, before we start, we know that f of x is equal to e to the negative x squared. And as we already solved in part A, we should get this endless polynomial which keeps on going. 1 minus x squared plus x to the 4th divided by 2 minus x to the 6th divided by 6, and so on. Next, the easiest thing to do is to substitute our polynomial into f of x. So instead of writing 1 minus x squared minus f of x, we are going to write 1 minus x squared minus, and then our polynomial, which goes on until infinity. And as you can see here, the first 2 terms of our polynomial of f of x cancels out with 1 minus x squared. So if after that you divide all your terms by x to the 4th. So what you end up with is negative 1/2 plus x squared divided by 6 minus x to the 4th divided by 4 factorial, and so on. And if you notice, from x squared divided by 6 until infinity, you're going to have x's in your numerator. And as our problem states, we want to find the limit as x goes to 0. So all these terms from x squared divided by 6 and so on will all turn to 0. So the only thing left over is negative 1/2 out in front, and that will be your answer. Part C asks us to write the first 4 non-zero terms of the Taylor series of the integral from 0 to x of our function f of x about x equals 0. And then using our first 2 terms of our answer, we are asked to estimate the integral from 0 to 1/2 of our function. Okay, first we should tackle 0 to x of e to the negative t squared. So if we write out the function, write out the integral, we can substitute e to the negative t squared with what we had in part A, which is the summation of negative 1 to the n multiplied by x to the 2n divided by n factorial. Now, we know this function that we just substituted in is equivalent to 1 minus t squared plus t to the 4th divided by 2 minus t to the 6th divided by 6, and so on. And all we need to do is that for the first 4 non-zero terms, we are just going to take the antiderivative of each term. For example, 1 becomes x, and t squared becomes negative x to the 3rd divided by 3, and so on. And this should be your answer. Now, the next part of part C, which will use the first 2 terms of your answer to estimate the integral from 0 to 1/2. So, our answer was x minus x to the 3 divided by 3 plus x to the 5th divided by 10 minus x to the 7th divided by 42. We are just going to use the first 2 terms, x minus x to the 3rd divided by 3, since the problem only asks us to use the first 2 terms to estimate. Now, Since we have the integral from 0 to 1/2, and we're using these two terms, by the fundamental theorem of calculus, we're just going to substitute 1/2 into x and subtract the upper bound from the lower bound from the upper bound. So if we plug in 1/2 into x, we should get 1/2 minus 1/2 to the third divided by 3. And we're going to subtract 0, because that is what will happen if we plug 0 into x minus x to the third divided by 3. Now, this will simplify out to 1/2 minus 1 over 24, which is just 11 divided by 24, which is our answer. Alright, part D asks us to explain why the estimate found in part C differs from the actual value of the integral from 0 to 1/2 of our function by less than 1 over 200. So, we know that in a Lagrange error, it is basically our next term. If you can see, the derivative is next derivative, and all these n's are you adding 1. So instead of the two terms which we were given in the previous section, we are going to look at our third term, which is x to the fifth divided by 10. Now, if we plug in 1/2 into our next term, we find out that it is equal to 1 divided by 32. Now, 1 divided by 32 is less than 1 over 200, which is why it differs from the actual value by less than 1 over 200. Now, you can explain this since the integral from 0 to 1/2 of e to the negative t squared, you can write that out as our summation. You can write that out as summation because we know our summation for e to the negative t squared, and we're just going to take the antiderivative of that. So instead of x to the 2n, we're going to have x to the 2n plus 1, and we're going to divide that by 2n plus 1. And instead of having x, we're going to plug in 1/2, since the integral is from 0 to 1/2. And we see that this new summation that we found, which is equivalent to the integral, is an alternating series, which means that the next term is going to be smaller in magnitude every time n increases. The next term will be smaller and smaller, which is why the estimate differs by less than 1 over 200. Now, I have some recommendations for you to work on in case you need more work on Taylor polynomials or Taylor series. So I found this website where the first problem is very useful because it's similar to part B in frq, which asks us to find a limit of a fraction. In addition, in your calc book, pages 747 and 756 have some pretty good problems which are really similar to the frq I just went over. Thank you very much for watching.